Okay, so what is Western blot? It is the usage of specific antibodies for identification of particular proteins from the mixture of proteins. So let's say you have your gel protein separated on your SDS-based gel, for example, but you do not know which protein is which. Okay, even if you know like from 55 is your protein of interest, but you need to confirm that it is your protein. It could be other protein, same molecular weight. Okay, so you need to use the Western blotting because Western blot use specific antibodies for tagging your proteins of interest. Okay, target protein are transferred to a hydrophobic membrane after page and detected using specific antibodies. So you have your gel here and you need to transfer proteins that is in your gel into a membrane. And then you can tag the protein with the antibodies the protein that is in your membrane. Okay, so the technique consists three major processes. So separation by the proteins, electrophoresis we already did just now, and transfer to a solid support means the membrane, and making target protein using a proper primary and secondary antibody for visualization. Right, so this is the principle. So the principle is about the specificity of binding between molecule interest, your proteins, and probe. So probe is your primary and secondary antibody. And you have to remember page is prerequisite for Western blot. You should start with the SDS page first. And then after you got your gel, and then you will proceed with the Western blotting. Okay, so the target protein is visualized as band on blotting paper or membrane, X-ray film or imaging system. Okay, so let's say this is your protein already separated by electrophoresis here in gel, and you need to transfer the protein in the gel into a membrane. Okay, so you cannot tagging your antibody in your gel page, so you require hydrophobic support, which is the membrane, in order to probe with the antibody for detection. So let's say this is your protein of interest. So in your gel, you will have your whole protein mixture separation from 10, 20, 50, 100, 150, 200 proteins. So this is your protein interest. You transfer all the whole protein from this extract into the membrane, and then you use your specific, let's say you want to tag here, for example, beta-actin. So you probe with beta-actin antibody, so that when you visualize under film, you will only see your beta-actin. So this is confirm the result from the page. Okay, so you will see your beta-actin here. So let's say you want to target different protein, you can use other antibody as well. So let's say here you use antibody specific to this band, the protein of your target. The protein of your target. Okay, so that is probing. Okay. So this is a step in Western blotting. Of course, it is complicated and require sequential processes in Western blotting, but this is just, I just make it brief. Extraction of the proteins, gel electrophoresis, and you will do your membrane transfer and series of washing with buffer, and you do your blocking. Blocking means to tagging, masking all the epitopes of your peptide antigen, so that when you immunoblot with primary and secondary antibody, it will recognize your peptide antigen that you already block in your hydrophobic membrane. Okay, and then you proceed with the detection. Okay, so this is, I couldn't find a very good picture for membrane transfer. So this is actually like this. So you will do a sandwich technique to transfer the proteins from the gel into your membrane. So you put your membrane here, and then you put gel on top, and then you incubate with buffer, like for example 1 hour. So it will transfer your protein from the gel into your membrane. Membrane is just a piece of paper, but it has its special abilities, for protein transfer. And then you do your blocking usually with skim milk. You use milk to block your membrane. and then we'll expose your epitopes, and then you will do the immunoblotting. Immunoblotting, you will incubate your membrane here. This is a piece of paper of membrane with antibody, labeled antibody, and then you will view using imaging system, or I still use a conventional traditional method which is using a X-ray film. Okay. Okay, so this is just a sequential step. Like you pour gel, pipette the sample, you run in page, and then you get your gel, and you build transfer sandwich. So you put your membrane here, your gel, and then you run it for like 1 hour, and then separate proteins on your blot, your membrane, and then you incubate with primary antibody, wash 3 times, secondary antibody, and then chemiluminescence substrate to expose your antibody for detection in film. Okay, so we will got this result. Okay, okay. So this is example of the result from SDS gel. So you will have your whole protein here because you do not tag your protein with antibody. So you will have your whole protein in lane 1, lane 2, and lane 3. But when you do blotting with specific antibody, so you will only see your protein of interest that's specific to the antibody that you use here and here and here. So this is much more reliable data compared to SDS. Okay. So if we see here the protein expression 4, 5, 6, which one is more highly expressed? If you look at here at the SDS gel, also it is the highest expression, right? Highly expressed here. But if you want to further confirm, we do the immunoblot. Still, it is the the highest, okay, to express the protein. The same protein, but different expression. Yes, the same protein, different expression. Same protein because it is in same molecular weight, maybe 50 something. Okay. So number 5 is the highly expressed protein. Okay. So that is the purpose of doing Western blot. So the application of Western blot for identification of specific protein in a complex mixture of proteins, and estimation of size of the protein, as well as the amount or expression of the protein in the mixture.